Okay.
Good morning. Right, it is 9, then we start sharp. Those that are late, they will remain late. We'll start without waiting. Okay. Again, good morning, everyone. If English is okay, or you want me to do more in Bahasa? Sorry? Both. Okay, campur. Alright, boleh. So, hari ini we are in the crushing and screening course today. So, today's session is about the process in crushing plants. Okay? Before we start, we go to the safety first. One quick question. Anyone know where is the emergency exit? There. But that door cannot be opened. That door is actually locked. If I will test for you, then what do we do? I was looking at the by one daily culture, and we will reach important than the business, or more important than the money. So for us, safety is number one. Alright? New safety that we have put in started introducing after COVID. Okay? We started introducing this new safety after COVID. Basically, because of the downturn and also the lockdown, many people got stressed. And this is something very dangerous. Okay, it will not show. But when it comes a hit, the sorry person might just want to commit suicide. So be aware. Next is a bit of myself. My name is Akila Wong. I'm a Malaysian Chinese, okay, from Semenanjung. I've been in Sandvik since, I started with Sandvik in 2002. Alright, and then I joined a customer of Sandvik, which is Gemencik Granite. Then after that, about 4.5 years in quarry operations, blasting, concrete operation, premix operation. Then I decided to join Sandvik again because I got bored in the quarry. Only one place, nowhere to go. After joining back Sandvik, okay, I am based in Shah Alam. This is basically my work or my my responsibility. I do flow sheets, that means I do plant design. I design new crushing plants and also optimizing old plants as well. Okay, I design new plants. I'm also project manager, okay, of building new plants. I'm also doing training like this, internally and also externally for Southeast Asia. I'm part of the global trainer of Sandvik, representing Southeast Asia. And I am involved in construction, that means the aggregate quarries and also mining, coal mining. Okay, what's now quarry operator? You don't operate quarry now. So how to turn this into that the customer can sell? Okay, by knowing the process, okay, at the designer point of view, then only you can actually know how to operate or maintain your plant in a better way. Right? First and foremost, we need to processing. Okay, we are only processing. We are not changing something to something different. Batu letup keluar, crush small, masih batu lagi. Okay, we are not changing like oil to plastic. Then we are manufacturing. We are only processing. Okay, so one thing, if okay, your sales, anyone from sales here? Anyone from sales or all operation? Sumo operation. If the sales tells you now, okay, I have orders for only this aggregate, yang lain saya tak mau, boleh tak? I cannot sell. Itu das tak boleh sell. I want only 3/4 inch. Is it possible? Is it possible in the quarry not to produce any dust but only 3/4? That is impossible. It is possible to produce only dust and no aggregate. Okay, but then when you produce the bigger size, you definitely will have the smaller size. So this is part of the process. Okay, it's not in the factory. Okay, we always use the example of a soft drink factory. Today, saya buat Sprite saja. Esok tukar buat Coca-Cola. We cannot do like that. When we produce, everything comes in. But the process, we can control a bit that we want. But we cannot eliminate the others. It's part of the process. And this process is all very influenced by the raw material itself. Okay? Some part of the Malaysia, itu state banyak abuk, tak boleh jual. Some part of the Malaysia states, tak cukup abuk, semua mau rebut. It's because the rock, not because of the market. Some of the rocks produce more abuk. Some of the rocks produce less abuk. So it's region by region based on the mountain they are blasting. Okay, there are some places like maybe in the northern or maybe in the east coast, whatever. Abuk tak cukup jual, semua mau. Then come to the Johor side, southern, okay, all have big stockpile of abuk. So it's not about the market. The market consumption is the same. It's just that the production is different. Because of the raw material is different. So we have the feed material, which is the rock. Then we need to have the machines and the process to make the product. So this is the process. So first we need to know what are we handling, the feed. We have first the raw material. We go through a drill and blast, loading and hauling, crushing and screening, then we have the end product. So this is the entire flow. Crushing and screening process. When does it start? Based on this flow, crushing and screening process, or the crushing process, when does it start? Any idea? Any answers? Any guess? No? It actually starts from drill and blast. Okay? Why do we say that actually your crushing starts from drill and blast? To be more precise, your crushing starts when you start to design your blasting pattern or drill pattern to the mind of the operator. Okay. That one we know. Okay. So that time when I was in quarry, okay, I purposely designed, okay, I ordered a custom bucket. So you can only take that big of a rock, so that you will never stop on my primary. So that's one way of doing it. Or if the rock stuck on the primary, I get the operator to come down and take it out. One time, two time, operator, station, price distribution. SD, using a lot in the quarry. Okay? We'll be using a lot. Then you have the WI. What is WI? What is WI? We, the PlayStation V? No. WI means work index. Work index. W-O-R-K, work index. So it is an index. Work index determines how much force you need to crush the rock. Okay, work index determines how much force you need. This index determines berapa cepat players, liners. This is AI. Then the last one is moisture. Moisture basically is about water in the material. Okay? So, on the fit point of view, on the properties, you have high influence at the beginning, but you have less influence to the final station when it coming there. Reason being, when your feed is coming in from the quarry phase, can you control? Can you control everything? Tak boleh kan? You cannot control berapa big size I want, how many big size, how many small size, how many small size. It depends on the excavator, satu bucket, load, that's it, go. You cannot control. Sometimes one truck, semua batu besar. And then another truck, semua batu kecil. And then one more truck, tak ada batu. Okay? So you can't control. So you have a lot of influence going to the primary station. Primary is working based on the truck or based on the excavator driver. But then when it goes down, you have the tunnel. You will notice bigger than your tertiary cone, but they are processing the same material. Ever cone mental concave cepat makan compared to jaw plate. Jaw plate makan batu besar, cone makan batu kecil. But why the cone wears faster? Yes, no, don't know, or don't want to know. In the primary, normally berapa besar setting? Or it depends on your quarry. Okay, so normally your one? 6 inch. 7 inch. 6. Any other numbers? Anyone set at 3 inch? 12 inch? Yep, some maybe 12 inch. Depends on your crusher size. But then on the tertiary cone, normally set how many? 3/4, 20 mm, 19, 25, 27. Okay, so when the setting becomes smaller, you have more contact space or contact surface. And also in the jaw, is it always full? Not always full. Sometimes full. Sometimes you look at full, but then because ada batu besar, so inside you have a lot of space. But cone, when it's full, is really full. And also you will see the cone have a higher working pressure compared to the crusher, jaw crusher. So your wear rate, of course, goes higher. So your influence of the WI and AI when it comes to the final station goes higher. Okay? Now it comes to product. The product influence actually goes the other way. Properties are the process, quantity, quality, product, capacity, product PSD, and loading out. So you have 7 here, you have 6 over here. The final station is the final station before you become a product. So whatever things you need to do, this is the last chance to make your product out. Your product shape, is it round enough, regular size, or elongated, flaky, panjang? It's all on the final station. But then when it goes up, you have less influence. Okay? Some very disturbing faces. This is just only the first slide. Alright, so this basically, if you can't understand, try and memorize. Then you might understand someday. But this is how we look at it. Okay? One thing about quality, how do we gauge quality? How do we measure quality? How can you say that this is a good quality product or bad quality product? I see there are some from the coal mine. So how do you gauge which is good, which one is bad of your product? Bagaimana check? Pakai apa untuk check? Atau lebih kurang sajalah, bolehlah. How do we check? Sorry. We will go very simple, okay? Then tomorrow you go very in-depth, okay? Maximum size, size distribution, index, moisture that we need to consider comes to, alright? Major rock type are very of igneous. Sedimentary rock is basically rock formation, sediment, next layer is almost so it's only pressed. It's not molten, easy to break. Okay, it's easy to break. So this is like sandstone and limestone. And it's quite unpredictable. Because you may have one layer of very hard rock, metamorphic. They are calcium carbonate. But one is like crystal. But one is limestone. Okay, just like carbon. High heat and pressure become diamond. But different molecular structure. Okay? The other one I always use, okay, for metamorphic. You all know Power Ranger? Old enough to know Power Ranger? Okay? So always before they change, what they say? The Power Rangers before they change. So normally they do the effect of material grain. So this is grain size for both. But from here, you can consider fine grain. You see the coarse grain, you can see the bintik-bintik and it's quite big. Okay? So when you look at grain size, okay, why do we want to know about the grain size? What is it? So when it's fine grain, the bonding is much stronger. When it's coarse grain, the bonding is less. Kurang apa? Banyak apa keluar? 0 to 5, a lot. Shape. Normally this, when it's blasted out or crushed out, is elongated or flaky. This normally, after crushing out, is this might need 4 stage to give a good shape. Okay, so the grain size actually okay, finer the grain, more flaky it will be. Okay, hour before. So now, the figure at the board, okay, P8, remember? Or P80 is 0 to 300 mm. Receive video? You don't have a question. How do you select? Easy. Okay, so scalping is part of screening. Later on, I see if I can find you some pictures of it. So you have a grizzly feeder, okay, with a separation size of 125 mm. Okay, Jadidia gap 125 in between. So if you put at 125 here, you draw a line, and different feed curve, the percentage passing to the jaw is different. This is considered a fine curve. This is only 0 to 300. So if you have a grizzly separation of 1 to 30% goes to the jaw. Others are, but if you go to a cost, 75% goes to the jaw. Same feeder, different blasting, your jaw capacity totally different. That also comes back when I say your drill and blast starts the crushing. If let's say it's only 100 tons per hour, this scenario, your jaw crusher only needs to take 30 tons per hour. In this scenario, your jaw crusher needs to take 75 tons per hour. But this is only 100 tons per hour capacity. Normally, we don't have so small capacity. If it's 1,000 tons, this is 300 and this is 750. So in the 100 tons per hour plant, you can use the same jaw, small one, for both scenarios. But when your capacity increase, these two jaw has a big difference. This jaw might cost double than this jaw. Maybe this jaw crusher is about 1 million ringgit. This jaw is easily 2.6 to 3 million ringgit. Okay? So how you do your blasting determines how you will set up your crushing plant. Okay? Also in this scenario, 30% goes to the jaw, 70% bypass. So you need a big conveyor for the bypass. This, you only need a small conveyor for the bypass. So if your plant designed for this scenario, it will fail here. If your plant designed for this scenario, it will fail here. This you can tell story now. This is about WI. This is how we test. Okay, what we do is this. Okay, size between 55 to 70. These rocks you need to find from the rock after blasting only. Pick those up. Okay, for Sandvik, we send our rock sample back to Sweden. Okay, for information, Sandvik is a Sweden brand. Our HQ is in Sweden, Svedala. That's the name of the place. And this picture is actually taken in our lab in Sweden. In the middle, and then release and let it hit the rock. First try, maybe it doesn't break. We change another rock, now we lift it higher. Until we lift to a position that breaks the rock, and then we do it again to confirm. There are numbers here, and that number will be your force needed to break a rock. Okay, work index. Some call it the impact test. Is and a very hard grind. Limestone, 13 plus minus 3. Okay, higher than 20 soft rock, and consider very soft. So softer, easy to crush. Hard to crush. Okay, make sense? No? This is the old way of scaling hardness. It's called a Morse scale. This I learned it in secondary school, in physics I think. But this is very general because you only have 1, 2, 3 until 10. But for the work index, we are more precise. That's crush. So the weight loss is the AI index. Okay, the weight loss is the AI index. to make sure that all our tests are relevant. Okay, this pedal, when we order in one big bulk, about, I don't know, 500,000 pieces. Okay, Sandvik, different brand, and they have their different batch abrasive index, and our AI will be different. It's not always the same, because the pedal are of different batch. Weight loss is the AI. Higher AI means the wear and tear of your mental concave, your conveyor, your wire mesh, liners are faster. Lower AI means less wear. So these are different wear rates. Granite 0.3 to 0.7, limestone 0.001 to 0.2. So basically it doesn't wear. Okay, I have a customer, material X is X, but when it exceeded, you will change this. Any small changes in your setting change. But here, it's quite stable when you have a smaller AI. Okay? Have you ever tested your rock AI? Or any idea? What is the AI? Don't know? Don't want to know? Okay. So as a designer, okay, you need to know. And also as an operation, you also need to know, because this is how you calculate and do your budget. And also your timing, your schedule for replacement. So normally the maintenance concave ke, tukar wire mesh ke, is it baru tukar? Nampak lubang baru tukar? Atau sudah tahu, lebih kurang, okay, this week we need to change. It's about time. Yes? So we were predetermined at least 2 weeks ago. Oh, just wait. Tunggu. Ya, tak boleh jalan. So lubang. Okay, buka. And then masa tu baru cari spanner. So we have the preventive maintenance, then we have the emergency maintenance. Okay? So a lot are actually doing emergency maintenance, not preventive maintenance. Crusher can take different hardness of rock. Jaw crusher, primary, gyratory crusher, cone crusher, row crusher, HSI and VSI. So basically all the other crushers are okay with almost all kinds of work index besides row crusher. Row crusher maximum 16 WI. Anything higher than that is not that you cannot use, it's just that the row crusher will fail much easier. Row crusher is not designed for very hard rock. You know what is a row crusher? Anyone that doesn't know what row crusher, please raise your hand. Because it's not common. Semua tahu? Semua tahu? You've seen a row crusher before? Have you seen a row crusher before? Semalam nampak row crusher? Ada? Okay. Tengok di gambar. Okay. Oh, tengok di gambar. Oh, semalam. Okay. Right. Yeah, semalam. I thought was the two beer barrel go together. So just imagine, remember, okay, row crusher is not for very hard rock. The others, okay. HSI, you have a big, okay, limit. So these two have limits. The others has no limit. Basically whatever hard rock, as long as it's not a metal. Apa batu saja, you can crush. Okay. Then we come to AI. Okay, we come to AI. So this is the wear and tear part. All crushers are okay. Row crushers is only for low abrasive. HSI only for low abrasive. These two need to remember. This is for road abrasive. It's not that cannot, boleh pakai, but you need to change your spare part, wear part, maybe every 1 to 2 weeks. Okay? Let's say you have a HSI. Then you process granite. Granite AI is about 0.4. From our past experience, we see every 2 weeks you need to change the wear part. Road crusher, 3 days. So it's not that you cannot use, you can. But your cost goes very high. These two are very cheap crushers. Cheap to buy, but very expensive to maintain when you're going to abrasive material. Okay? So far so good? Still here? Ada tak yang ada tapi tak ada punya? You're here but yet you're not here. My session, okay? Okay? The density now. Because how a product sell? By ton or by meter cube? By ton. Okay? Not by meter cube. We sell by tons. Some countries still sell by meter cube. Okay? So they load to the truck, tekan. Still meter cube. But we are better, we sell by the weight, by tons. Okay? So that's more, I would say, fair to everyone. Okay? So from the solid density, you can find the bulk density. So what is the difference between the solid density and the bulk density? Upper base. Density of one rock is solid density. Density of a bucket of rock is bulk density. Can you get me? Another example, your rock reserve. Okay, your rock face reserve, gunung. Which one you use? Bulk density or solid density? Solid density, because it's one piece. Your stockpile, you use bulk or solid? Bulk density. What is the normal bulk density for aggregate stockpile? Then how you calculate your stockpile? Call for surveyor, lebih kurang. Ada bos kap. Okay lah, lebih kurang 10 ton lah. Stockpile. About that volume, yeah, that one is about 10,000. So we need to know the bulk density to do a correct checking. Okay, we need to have the bulk density to do correct checking. So how to find the bulk density? Either you use the formula or you go for lab test. Okay, how do you find it in the lab test? Take a container of 1 meter cube, fill it, and then weigh it. Then you get your bulk density. Okay, fill it but don't compact, just fill it. Yes, we know it has a higher 3/4 inch. You have less watts. Memorize. Next factor is the moisture. Next factor is the moisture. Okay, we have the dry, then we have the soak condition, then we have a saturated condition. Soak condition is when you have water dripping. There's free water. Saturated is it's wet, but then there's no water dripping. Okay? Do you normally buy river sand? Do you buy river sand? So when the truck comes in, okay, and then you see the bucket dripping water, that one reject. You have at least one. When you have all, why? Absorb, contain more water. Why the fines can contain more water? Because of surface area. Surface. So because of surface area. What is surface area? What is surface area? So now we go back to high school. High school physics. What is surface area? So it's basically the area, then you have the surface area, right? So because in the same volume, you can have more fines than more costs. In the same volume, dalam satu bucket, or let's say in this bottle, okay? One question, one bottle of Abo and one bottle of 3/4, same bottle, mana satu lagi berat? Abo. Hence you can, this is with only, and actually 10 times more. Sorry, more fines is Abo and DCR. Because they track more water. Coal, normally what is your moisture content? Let's say when you just got it delivered. Normally what's your moisture content? You normally do a lab test, right? And then check the moisture content. So what is the normal moisture content? What is your size first? What is the maximum size of the coal that you take? Size berapa? 100 mm? 50? 50 mm? Masa you beli 50 mm? Tak. Masa you beli lebih kurang 190? Before crushing? Ya, 300 mm? Lebih kurang. Okay, so ada yang Abo sampai 300 lah. Ataupun semua 300 saja. Tak ada yang fine. Mix. Okay, so what is your normal moisture content? Test before? Ada test tak? Different department. The last I know from TMB, they got the coal from Indonesia. Okay, when the vessel enters and then they did a test, it's about 14%. After processing go through the plant, it goes up to 28%. Because they have sprinkler system. So it becomes 30%, doubles up. Okay. Later on we discuss, okay, what is the effect of moisture with fines. Alright? Okay, so getting warm. Now we have it engine up. In normal feed, moisture in typical crusher feed can be about 1 to 1.5%. Normal, because you have the coarse material. Okay, but then when you have a fine material, it can actually goes up a lot. And moisture actually reduces the crusher capacity. Okay, moisture reduces crusher capacity. Let's say you have 1% of moisture, actually you have lost 1% of rock. That 1% is only water, it's not rock. So when you bloody coal, your moisture content is 14%. So actually you have lost 14% of coal. Maybe you need to deduct. Yeah. Deduct the price, okay. Totally just use 1,000, then you can deduct 40%. Same that we goes when we buy what is called buying the river sand. We also do moisture content test. If it's below 2%, okay, we say it's okay because that's normal percent. Higher than 2%, we need to deduct. Okay, so far so good. Contaminations. This is one of the last factor of the raw material. Contaminations. In general term, what is contaminant? In general, what is contaminant? In very layman terms, is whatever you don't want in your end product, or whatever the customer is not paying for. Okay? As inside the aggregate of Chengai wood, contaminant, because or your customer is not paying for is wood normally. What else in the quarry? Steel, yes. Bucket tip. Drill bit. Don't know what piece of metal dropped from the screen. Wood, branches, rubber. Anything else? Bayan. I've seen a cat before. Itu kucing tak tahu buat apa, dia masuk quarry, dia masuk crusher, dia keluar. But in different pieces lah. Okay, so whatever you do not want, the customer is not paying. Or what is the contaminant you normally have? Packing. So, but the Kimberlite ore itself, plastic plate. First thing, it doesn't break. It will continue compact. Okay, those quarry capacity reduced by 50%. So that means if that plant you put for aggregate production, you can do 1,000 tons per hour. If you put in Kimberlite ore, you can only do 500 tons per hour. Because of play issue. So with this plant, these are actually, so in that 1, 2, 3, 4, 5. Don't know. So half a the world. So trying to get the rocks from the moon. So that's quite impossible because China is not giving good growth. Next, which is contamination. No. Our anyhow, let's start. Okay. Now we go on to the next slide. Let's continue what I've stopped. Next one is about reduction ratio. Okay. So reduction ratio is how much you can reduce, or what is the maximum that a crusher can reduce in terms of size. Let's say if you reduce 100 mm down to 10 mm, what is the reduction ratio? 10 times. 100 divided by 10, you get 10. So reduction ratio is 10 times. If 5 reduced to 2, if 5 reduced to 2, 5 mm reduced to 2 mm, 1 point, is it, or 2 point? 2.5. Okay, so it's 2.5 times, so it's like that. Okay? So normally reduction ratio, okay, we always use the F90 divided by P90. Okay? Your feed material, 90% passing, what is the top size? And then your end product that you want, 90% passing, what is that? You divide those, then you get the ratio. Okay? One thing about it is about the jaw crusher. Okay, jaw crusher to us, the most important one is actually the nip angle, which is the angle between the two jaw plates. Okay, this is called the nip angle. If the angle is too big, you have not enough grip for the rocks to go down. The rocks will continue jumping. Okay, if the angle is too small, it's almost like a chute. So we want to have the nip angle, and the nip angle is 20 to 22 degrees. Okay, this applies to all jaw crusher. All jaw crusher, 20 to 23 degrees. Okay. Before that also we have said when you have too much fines and then you have moisture, it becomes a lump. And that lump will actually causes very high pressure in the cone on the crusher. That we call it packing. Okay, so we need to remove the fine materials before crushing. So what is fine material? What is fine material? In different stage, it's actually different size. At the primary stage, let's say your jaw crusher setting CSS 200 mm. Okay, your jaw crusher setting 200 mm. What is the size of the fines? So since your setting is 200 mm, whatever is smaller than 200 is considered fines for the jaw crusher. So your secondary setting at 50 mm. So the fines are minus 50 mm. Your tertiary cone setting 20 mm. Your fines are minus 20 mm. Okay, in a process point of view, fines is not about dust. It's about whatever material smaller than your CSS is considered fines. Okay? Clear this one? Mungkin ada keluar. Tadi ada orang tanya saya ada keluar apa? You hafal the whole book, then okay, no problem. So you have the setting CSS, and then you have the nip angle. That is where you get the grip. Okay. Here we use the PAT and the FAT to calculate the reduction ratio. Okay, F is your feed, P is your product. So whatever passes the 80%, you draw the line and then you get the two numbers. F is 350, P is 75 mm. So you divide these two together, then you get the ratio. So in this process, we reduce the size of the rock 4.67 times. Okay, 4.67 times. So why do we need this? Because every crusher has their maximum reduction ratio. Example, jaw crusher, typical reduction ratio is 2 to 3 times only. Giant tree, 3 to 5. Cone crushers, 3 to 5, 3 to 6. Impact crusher, HSI, 5 to 15 times. Roll crusher, 2 to 4 times. Okay, so just now we have this 4.67. One stage, not enough. Let's say you're only using the jaw. Maximum is only 3 times. So we need 4.67. So in this scenario, single stage crushing is not enough. But if it's small enough, you actually go through a CS, then this is sufficient. 1 times crushing. Or you go through a HSI, more than enough. Okay? So that's why we need to know the reduction we need to do. Then from there, we determine how many stages of crushing to use and what crusher to use. Now, something is different here is VSI. It tells C next slide. Okay? If this question comes out, please don't put the answer C next slide. Okay? Why is it? Because of this. Now, we have a same feed. We have this material go through a cone crusher and go through a VSI. So this is after going through the cone crusher. This is after going through the VSI. If you look at the top part here, the top size actually is the same. The feed and the VSI. So it actually doesn't reduce a lot. But the cone, if it reduces the size from here, this is 10, 20, 30, 40 mm, reduced to about 22 mm. Okay? But in the VSI, you can look at it, the curve become a finer curve. This is a coarse curve. The more steep it is, the more coarser the material, the more of a slope, then this is considered a fine curve. So you have more fines from the VSI compared to the cone crusher. And on different stage, you have different reduction coming out. So it's about the same at the 40% point, but the VSI actually do more crushing at the fines. Okay, they do more at the fines. So that's why, in a way, I've said before, VSI, rock to rock type, is actually not a crusher. It's more of a shaper. Unless it's rock to metal type, that is a crusher. Okay? Clear? Next, when we design the crusher or plant, we need to know when to use open circuit, when to use closed circuit. First thing, what is open or closed circuit? This is considered open circuit. Goes in, direct goes out. Closed circuit, you have return. So you have a closed loop. So this is considered closed circuit, this is considered open circuit. Normally at the jaw primary station, is it a closed or open circuit? Yes, you have open circuit because nothing returns back to the crusher. It's all direct crush and go out. Okay, secondary, some closed, some open. Depends on the condition. If you only want to produce DCR, then you close it. If you want to produce aggregate, you open it. And normally at the final third stage or the fourth stage, it's normally closed circuit because you want to have good shape. So you reduce coming back. So you have an open circuit and a closed circuit. What is the pro and con of open and closed circuit? In open circuit, let's say this crusher, I say this crusher is a 250 tons per hour crusher. In open circuit, it can definitely do 250 tons. But in a closed circuit, because you have the return coming in, even though it's still processing 250 tons, but actual coming out is less than 250 as end product. Because you have maybe 50 tons is actually recycling. Okay, it reduces the capacity, but it gives you better shape. Alright? Crushing in open circuit, screen you can put in front of the crusher to avoid packing. So we remove the fines. Okay, again, what is fines? Whatever smaller than your CSS is considered fines. Okay, so by removing those fines, you actually reduce packing and you have less wear in the crusher. You increase capacity. The size of the final product is calibrated on the screen and with the setting in the crusher. So, if this is 50 mm mesh, all those coming out is minus 50, but whatever coming out from this, even though you can set, let's say 50 mm or maybe you set 45 mm, but depends if you're choke feeding the crusher or not. Are you doing the setting regularly? The product coming out may be changing. So this is a calibrated product. This is a non-calibrated product. Okay? Okay? Alright. Then you have the closed circuit. So all product coming out must go through the screen. So this product is 100% calibrated. The good thing is you have a higher reduction ratio with better shape, but of course you have the slightly downfall. You have a lower net capacity. Okay? So this crusher is still producing or operating at 250 tons per hour, but whatever come out here is actually less than 250 because you have the material going back recycling. Okay? So normal in aggregate, okay, we use closed circuit. Normally in mining, we use open circuit. Or depends. Or maybe in coal also we use open circuit maybe. Because you only want minus 50 mm. You don't care about the shape, how many spines. Okay? You don't care about those. You only want minus 50 and then go to the boiler. That's it. Yeah. Crushing in closed circuit. So you have the return coming in. Okay, the return, oversized, recycling, okay. In general, okay, we only allow maximum 40% coming back. Okay, we only allow maximum 40% coming back. If it's more than 40%, okay, you find the issue that, okay, even though it's running, but nothing come out. At some time, you need to stop your feed. Let the circuit finish, then only you can add in new feeding. Okay? So this is when your recycle or return has been more than 40%. So what's the problem then? If you have this kind of problem, what's the issue? What's the issue? Setting, wrong setting, setting too big. Okay? No one checked. So you need to change the setting and you will have it done. Or maybe crusher cannot be set anymore. Liner finish. Yeah, one concave, one mantle. Or crusher has an issue, cannot set. One set small, okay, then you got high fever. So you have internal parts issue. So normally the CSS is recommended to be smaller than the separation, but sometimes can be bigger, depends on your rock. Some rock is easy to crush. Some rock you set 20 mm, you come out actually 16 mm. Then you need to maybe set 25, 28. Then you come out 20 mm. Okay? So it depends on what material you are handling, or what condition. Next is about the storage. Okay, the rock hopper here is also considered a storage. Okay, we have a general rule. Suitable live volume is 2 to 3 times the truck load. So let's say your truck is 40 ton load. Your hopper need to be at least 80 ton to 120 tons load. And it's live load. Live load means, okay, sometimes you have a box type. So the side there is considered the dead stock. You will never move. So you need to have a live load. For example, you have a rock hopper like this. Okay, this area material will never be going anywhere. It's always be there. So your live load is only this part. This part need to deduct out. Also like a stockpile. Okay, you have a tunnel down here. Right? Then you have a feeder. 1 feeder, 2 feeder, tunnel feeder. This area is your dead stock. You will never move unless you use an excavator, try to dig it out. This is your live stock over here. Okay, so we calculate by live volume, not volume just. Normally, for one truck, or not say for one truck, yeah, for one truck, okay, to reverse Dump, put down the bucket and go away. Normally how long it needs? Berapa saat? Berapa minit? Atau berapa jam? Normally? Anyone calculate before? Anyone ada pergi timer time? Tengok. Never? It's about 2 to 3 minutes. Okay, it's about 2 to 3 minutes. So 1 hour 60 minutes maximum you can load, you can dump about 20 to maximum 30 load. Normally we use 20 to do calculation. Okay? So if your primary is 500 tons per hour, okay? Your primary is 500 tons per hour. Then we know that we can only load 20 load per hour. How big my truck should be? How big my truck should be? Berapa besar truck itu kena ada? Berapa besar? 30, okay. Minimum? So 500 divide by 20. Berapa? 25. So minimum 25 ton load. Minimum. Then your hopper need to be minimum 50 to 75 ton. So that's how you calculate. Okay, this is how you match. So just now the scenario, I need a minimum 25. Tapi yang pakai lori hantu saja 18 ton. So cukup tak? Tak cukup. You berapa cepat pun tak cukup. Berapa banyak lori pun tak cukup. Okay, because every time it's about 2 to 3 minutes for that cycle. Every 1 hour, 20 to 25 loads. If everything goes smoother. Okay, terus saja. So it's about 20 to 25 load. So you put a too small truck, cannot. Okay, so this is what we call the feed issue. Okay, feeding issue. Still here? Baru setengah jam sudah somewhere else. Okay, hang on. Then the next one is the surge pile with the tunnel feeder. Why do we want to have a surge pile? Why do we want a surge pile? Primary surge pile, then only go to secondary. Stock. For? Constant crushing. Basically, we want to separate these two stations. So let's say you have this surge pile. Okay? You have enough material, you do maintenance here, your cone still can run. Or you have a big hole. Your cone now need to do maintenance, your primary still can run. Okay, so to reduce downtime. Basically to reduce downtime. Okay, how big is the tunnel? Or how big is this surge pile need to be? We recommend the bigger the better. But at least one shift. Minimum one shift. So one shift is maybe 8 hours or maybe 10 hours. Depends on your crushing size. Okay, let's say it's 500 tons per hour ton. One shift, 8 hours. Berapa ton? 4,000. Yeah. 4,000 we need live volume. Not just volume. Live volume. Like this, if you have 2 pan feeder, you need to take out this, take out this, take out this. This is about, I don't know, 25% or maybe 15%. If you have only 1 pan feeder, you need to take out 30%. You only have 70% of live volume. Okay? not very okay. The other thing is also that we always like to have a bin before the crusher. We call it high bin. Sorry. High bin. So the bin have the rod and immediately with the feeder direct feeding to the cone. Okay, even though you have a surge pile, but then the surge pile you still want to have a bin direct feed to the cone. Even though the surge pile, yes, you have pen feeder, you can control the speed. But there's a distance from here to there. Okay? Maybe 10 seconds, maybe 5 seconds delay. So let's say you have full here, you increase or you reduce. By the time it reaches, it's already clear. Okay? Or this is not full, you increase. By the time it reaches here, maybe this is already overloaded. So that's why we want to have a bin directly before the cone crusher so you can have immediate reaction. This is immediate. So you can always choke feed the crusher. Immediate reaction. This goes to the secondary and also the tertiary. A lot of plants don't have this. Why? Yeah, save money. Boss say budget not enough. If I buy the bin, I got no money to buy my Ferrari. Okay, so we always want to have a bin. That is the best practice. You have a tunnel, and then you have a bin. Always. You will see that with or without a bin, your efficiency or your crushing capacity actually have a big difference. Easily to 20% difference in terms of efficiency. Now we have circuit, we have screen before crusher. We have another screen before crusher. This one is actually a bypass, it's two product. This is a bypass, the product adds together. And you have this one is a grizzly before crusher. So all of these are considered open circuit. Okay, all of these are considered open circuit. Then this is a closed circuit example. Feed to cone, cone to screen, oversize back to cone. This is after screening, goes to cone, cone come back. This one is two screens, before and after. So anyhow, when you see a loop, okay, that is considered closed circuit. Okay? Still here? Only one person. Since you're a bit lazy, doozy, whatever, Z, okay, let's do some calculation. Okay? If you can, bring out your calculator, or you can use your handphone calculator, and then we do some simple calculation. So this is a scenario. You have 200 tons per hour of material coming to the screen. The screen has a separation size of 16 mm. Alright? And after the screen, the oversize goes to the crusher, and this undersize just passing out. So this is the condition of the feed. The feed have 50% 0 to 16 mm and 50% of 16 to 45 mm. So please calculate this and this. What do we have? Kira. If you are very good at maths or you're familiar with maths, just 50%, 50%, so it's 100, 100. Because 50% of the size, we are taking as the perfect condition. Okay, so 100% accuracy. So 50% of 200 is 100. 50% of 200 is 100. Because whatever goes to the cone must come out. You will not become more. Also, you will not become less. Okay? The cone will only process your rock. Dia tak akan makan your batu. Okay? So this is the simple one, open circuit. Next, we have closed circuit. 200 tons, same, coming in, goes to the screen. Oversize goes to the cone. After cone, it returns back to the screen. Undersize comes out. Fit condition, 50%, 0 to 16, 50%, 16 to 45. This is the fit. After going through the cone, you have some crushing action. Material, 75%, 0 to 16, 25%, 16 to 32. So please calculate total amount of material that's actually going to the screen, amount of material going to the cone, amount of material coming out of the cone, and also the end product, TPH. You have the answer on the next page, but please, you need to know how to calculate and why. There's one answer here that don't need any calculation. This one. This one you don't need calculation because whatever goes in must come out. So you go in 200 tons per hour, it must come out 200 tons per hour. This you need to calculate. We do this one time together. Then you will know how to do. So we have 200. You can see. Going in to the screen. Oversize. Go to the cone. After the cone, return back here. Then you have the product outside. So since it's 200 going in, 200 must come out. So this one you don't need to do calculation. Immediately you can write 200, the answer. Then you have this combined. So this 200, based on the condition, 50% goes to the cone. 50% of 200 is 100, right? So we have 100 here. This 100 goes through the cone after crushing. You still got 100 coming out. Then of that 100, 75% become end product. Right? Okay, this one, let's put it this way first. Oh yeah. So 75% will come inside here, go out, which is 75 ton. 25 still oversized.
Yeah.
Go back to cone. Okay, so you need to add 25. This 25 come out, add 25. 25 go to the screen. This 25 also the same. 75% goes to end product, 25% need to return. Okay, so what is 25% of 25? Yes, please use your calculator.
$18.75 18.75
25%哦
，75还是25%？
25%回来啊，6.2 Okay?
OK，再加6 OK。
Right? This 6.25 still not end product. Still need to go through the code. Again, 78% go out, 25% need to come back. So 25% of 6.25 is how much?
1.56。1.56。
1.56. This one also still need to go through. Because there's about 1.5 tons of material. Go through again to the cone, come out again. 25% of the 1.56 is how much?
0.39。
Okay, add all this up together. I think you get about 133. Yeah, you get about 133. So this 133 goes in, add together with the 200, so you have 333. So even though your feed new is 200 tons per hour, but your screen needs to handle 333 tons per hour. Okay? So you see here, the material has gone through and recycled how many times? First time, second, third, fourth, fifth, or maybe a little bit more. Okay? So this is what it happens in the new scenario, in the real scenario. Material doesn't go in and out directly. Come 2 times, 3 times. So if your material, your setting is too big, let's say we go the other way. Now, 75% return, 25% go out as material. How many times you need to cycle? Okay? So this is how we calculate. There's an easy way to calculate, okay, as per shown in the book. Is whatever coming in, the 100 tons, you divide by the 75%. Immediately you get 133. You can try. 100 divided by 75%, which is 0.75. Got it? Got it? No? 100 divided by 75%? 133. 0.333333. Right? So in the earlier days when we're doing plant design, we calculate like this manually. Okay, a lot of data needed. But now easy, now we have program automation. Okay, we can do plant design much easier. Okay, so this is one exercise. We go to the next one. Please do your own calculation before referring to the answer. Any question? Raise up your hand, I'll come to you. Ingat sudah start kerja tak payah buat matematik lagi lah. Anyone needs help? I'm not sure. Looks like okay. Yep, looks like okay. Mm-hmm. Then you need to add up all together. How are you doing? Why is this 49? Yeah. 但是这边是变2边50-50了。100除58%，为什么100呢？只有70%过去可是，所以基本上只有70吨去可是，所以是70除58%。因为58%是 end product。OK。 可以吗？好，对吧？不要闪烁。大概是对这个，但是再出多一次这个，要0点一下的，才比较 accurate。OK 了啊。说总数多少？100 masuk, okay? 70% go to code, okay? Tinggal 30, tu biarkan dulu. 70 go to code, lepas brushing, 50. 70 keluar brushing, masih 70. So sini ada 70. Okay, ini 70, 50, 50 go out, 50 come back in. 50% of 70 is end product, 50% recycle. So yang lepas screening 35 balik sini. And sini pun 35. And 35 go again. So half. Yes, until you get a 0 point something. Then you add up all together. So this starting is not correct because it's 70 tons going into crusher. Your 70% is oversized. So 70 goes in after 50% is 35. So 70, 35, 35, then half. Yeah. Okay.这多少来着？差一点。少了哦。谁搞惯了？你的呢？背掉2吨。no， 也不对。没有啊，你100吨进永远就是100吨出而已的嘛。那个是在里面循环，不然它不出去的。OK， 如果你要这样算也可以。OK，100下去，38在这边出来了，对不对？70回去，对不对 ？OK，so 最后就不是244了，这个一开始是先30。对 ，OK， 然后那70过来这边。然后经过这个过后，58%的70就是35跑来这边，35又跑回去这边，OK， 说30加35，35进去又一半，就加那个，你这边加上去，所以这个加起来到最后还是100的。 这个要把这个总数再加这个加起来，就等于这个。所以如果你这个找到是140，140加100就等于这个240。
哦，OK，所以这边还是240。
对。
这个还是只有100。
只有100，对，因为你怎么都是进100亿嘛。
但为什么会说这个就会变成
因为这边有循环嘛，一直在这个位置在转。
所以其实这个主要是算说它的空做了多少功，
要循环多少次然后你的 screen 要多大个？
才算你的 screen 要多大个？
对。
我的 screen，
可能
这个空是这样子，
有这样的 setting， 这样的东西进来，这样的情况下，我的 screen 要多大个？然后我的皮带要多大个？
OK， 所以其实我还有一个问题，那还有一个题目是其他的，我的 screen 那个也是会懂，就是因为。
Okay, welcome back. Please look at this flow. You have capacity coming in, 300 tons per hour. Go to this jaw crusher. The machine load is 63%. Then the material after crushing goes to the screen. That is 60 and 25. Oversize go to this cold crusher. Machine load is 41%. Intermediate size go to this crusher. Machine load is 99%. What do we see here? Any issues? Or able to see? This machine load is 63%. This machine load is 41%. This machine load is 99%. Any problem? Yeah. Any problem? No problem? All good? All good? So there's one big problem here. This machine is only 41% load. This machine is 99%. So basically one machine is working very hard, the other machine got almost nothing to do. Okay? So this flow is not balanced, it's not fully optimized. Because one machine is working too hard, very hard, one machine is not doing much. So in your opinion, what we can do here? What can we do over here? What setting? Which crusher? This one? And then what do you want to do with it? Change the CSS? Smaller CSS. Okay. Any other idea? The product we want is only the minus 25 mm basically. There may be an issue here. This crusher is not choke fit. So probably we can add something to it. No, maybe just changing or adding a level sensor. Yeah. Okay. With level sensor, we can make sure the crusher is choke fit. So at the different levels, if you have bin, then you have the crusher level sensor. So if the crusher level is low, it will control the pen feeder to vibrate faster. If the level is too high, it will actually slow down or stop the pen feeder. Then at the same time, if this bin is too low, it actually stops the pen feeder. Because when you're feeding only a little bit to the crusher, might as well don't feed at all. And also if the bin level is too high, it will actually control the feeder in front, maybe the tunnel, okay, to stop or reduce speed. Then all the way, you can make sure that your crusher is always full and not half full. Okay, that's one way to do. Something like this, a level sensor. This is an infrared level sensor. So when the material goes up, it will cut off the signal, then it will tell you the feeder to stop. And when the material goes down, then you have a signal, then the feeder will start again. And you have other type, it's called the infrared, this is the ultrasonic level sensor or level indicator. So this is a bit different because it can have variable levels. You can set low level, high level, high level. Then your feeder will go slow, fast, and not shut down, open, shut down, open. Okay? That's one cheap way to do. Or actually, maybe you can do something about the flow itself. So now we see this is 41%, this is 99%. So obviously this crusher is not working. This crusher works too much. Probably we can do something about here on the screen. So give more material to this crusher. The screen now is 60 mm. We can probably maybe lower it down to 40 mm. Then you have more material going to the crusher. So now this crusher becomes 80%. And previously it's 99, now it's 98. And because you have more product going out, we can actually increase the production to 400 tons per hour. So just by changing the wire mesh aperture size. Okay, optimization of a plant doesn't mean that you need to change machine. Sometimes it's just changing some tuning, CSS, wire mesh deck, itu saja. Okay? If you have a problem, first you find where is the bottleneck. Don't change the crusher. Some will say that, oh, like in this scenario, some will say, oh, this is the bottleneck, 99%. We change it to a bigger crusher. You can, but then the investment is high. This scenario is only changing the wire mesh. Wire mesh you need to buy anyway. Now it's just changing a different aperture size. But by changing that, which is a very small investment, you increase the entire plant capacity for another 100 tons per hour. Okay? That is the exercise we need to do to your plant. Find out where is the bottleneck. Find out the root cause of the bottleneck. Maybe today afterwards we can have a discussion about the bottleneck that you have. The other way is actually changing the eccentric. So this one is not doing a lot. We change the eccentric, okay, to a smaller eccentric bush, smaller eccentric throat, and then what we do? We also reduce the CSS at the same time. We have changed this as well. This one we increase the eccentric. By that, we actually can add another 50 tons more to the system. So now the plant, with everything the same, no new investment, no need to buy new things, just fine tuning. Your plant from 300 tons per hour now becomes 450. Okay? So the first thing is always find the bottleneck. And then first find a way that costs less to solve your issue. Changing machine is always the last option. Okay? Changing the equipment is always the last option. So this is the difference between a sales guy and a technical guy. Salesperson will tell you, you change this question, you buy this one, can solve your issue. Technical person will come over, okay, let's work together. Okay, let's see the plan. Find out the bottleneck. See what we can do, fine tune first. Okay? So optimization process. First, change the separation size on scalping stream. Select correct crushing chamber. Change your setting or central. Maybe add a new surge pile. Last, only consider replacing the equipment. Okay? The last, only you consider replacing the equipment. Any question? One thing good about this class, because no one asks questions, so we go very fast. But also one thing not very good about this class, because no one asks questions, I don't know if you don't or don't know. So it's a bit worrying. We will see after the exam. So in Sandvik, we have a Plant Designer. It's a software program, okay, that we do to do simulation. Okay, simulate. And because it's just a software, we can do whatever we want, change whatever setting, rearrange everything, okay, and do simulation, see which is the best solution before we actually go to the real world and start doing things in the real world. Okay, so we can do simulation. We can do simulation for old plant and also for new plant. And this program for us is very accurate. We use this program, we use the flow as part of our contract guarantee. Okay? Difference is about plus minus 10%. So for quarry, industry, process, 10% plus minus is a very good accuracy. Others will have their own program. I think you also have one which is open for all. It's called AgFlow. Okay, I think you can subscribe for it. And AgFlow is a bit more general. Okay, it's not very in-depth. You can change a lot of things in AgFlow. Even if the flow doesn't balance, it will still say okay. You will have no warning. For us, our Plant Designer, we have warnings of each and every one. Okay? Next one is about the screening media. Okay, in screen, besides the screen itself, the next most important thing is the screening media. What screening media you normally use? Wire mesh, rubber, PU, steel plate, piano wire, hard wire, a lot. So of course, normally the most economical one and most available is wire mesh, woven wire mesh. Okay, in Sandvik we have other types of screening media, which can be used not just in our Sandvik screen, but also any other brand. We have this, what we call the WX6500. This is actually a rubber mesh to replace the wire mesh. This has 65 to 75% more life compared to normal wire mesh. Of course, it's a bit more expensive than a wire mesh, but it lasts long. Okay. This is mainly for high performance screening for stationary or mobile application. We have separation size from 2 mm until 32 mm. So this is basically for fine screening. 2 mm up to 32 mm size. The funny part of this wire mesh, rubber mesh is, okay, it's made in Sweden, but the raw material is from Malaysia. The raw material, the rubber is from Malaysia. But we haven't able to do it in Malaysia. So it's a bit expensive because of the tax. So let's see if I can open a new factory here in Malaysia to do this rubber mesh. So this is the slogan for the rubber mesh we have. Soft like steel, lasts like rubber. So it lasts about 3 times to 5 times longer than a normal wire mesh. Okay, the price is about double of a wire mesh. So still worth it. Anyone interested? Yes. Open space is quite similar to the wire mesh. It's quite similar to wire mesh. The main thing about rubber mesh is, okay, is the material ingredient. The more raw rubber you put in, the better the quality. And it's better on the strength as well. This is a bit of a marketing statement. Okay, so it's about 10 times longer life, 1/3 of the weight, 75% faster installation, and 50% quieter. So less noise, less what we call the noise pollution. Yeah, noise pollution. We have a lot of other medias. Rubber, modular rubber, anti-blinding rubber, PU. We have our own wire mesh as well, but that is not the normal MS wire. It's a bit different. Okay, we have also tension, anti-blind PU, and a lot. For both coarse and fine rock application. Okay. Then next is about wear protection. Okay. Where do you use the wear protection? You use it in the shoe work, rock box, even your truck bucket, your excavator loader bucket. So you have wear and tear, then you need to have protection. This is one of the highest costs actually sometimes in a lot of quarry. So normally what do you use for that liner? What do you use? Let's say for the truck bucket, what do you use as a wear liner? I've seen people using the old rods, drill rods. Then they put it and weld it on the bucket. Some use the old jaw plate, used as liners. Of course, the better one, they use AR plate. Okay, some maybe use rubber. We have something called HX 900. This is a cast-in carbide. Inside is actually casted, cemented tungsten. Okay, then we have ceramic wear plates, and also we have rubber plates. So these are for all application. This is one example. This is what we use. Cast-in carbide is used not just for the chutes, but also for crushers, excavators, and some of the premium crushing parts we use this material. This is rubber liner. It's light to medium application, noise reduction, normally used for chutes, bins, hoppers, and feeders. This is ceramic liner. This is mainly for abrasive and sticky material. Abrasive and sticky material. This is the application selection guide, and this is some of the business case that we use. This is the application that we use. We use the HS900. This is in a copper ore. The application chute is minus 400 mm, so it's a coarse material. Previously, they were using HardDocs 500. Okay? Same size, same thickness. The HardDocs last for 1 to 2 weeks. The HS900 lasts for 11 months. Okay? So it's 27 times more life than the HardDocs, and 9 times more in point. The price is about 5 times higher than the HardDocs. But it lasts 27 times more. So is it cheaper or more expensive? You do the calculation. Okay? You do the calculation. This is another one. We use rubber liners for this Germany quarry limestone quarry. Maximum size 150 mm, 5,000 tons per year. Use a hopper liner. So the liner was there since 2010. So it's more than 10 years now. Never changed the liner. Of course it's limestone, but then this is a bit of a slightly abrasive limestone, light abrasive. So if you're using HardDocs, it actually can last for maybe 3 years. But again, because HardDocs is metal, so it's quite noisy. So they have an issue also because of the noise. So once they use a rubber liner, they've reduced the noise by more than 50%. But then also the liner itself has lasted much longer. This is ceramic liners. We use it in the gold mine. Okay? So it actually has a 6 times longer life than the HardDocs. HardDocs there only last for 6 weeks. Ours lasted for 9 months. Good? Mount? Price can always negotiate. We always have different packages. Can do installment. Just talk to us. Everything can do, isn't it? Right. Then we have some crushing chamber optimization. This program we have been doing for our own crusher, but then the problem is we have stopped the simulation. We actually have software to do simulation, but this is now stopped. It's now only available in the R&D department of Sweden for Sandvik. Previously, I have the simulator, so I do it for the customer. But now they have taken it back. It's only for the R&D engineers. So if I need to do such simulation, I need to get the information and send it back to Sweden for them to do for us. This is actually to select the correct type of crushing chamber for your application. Maybe you want more aggregate, less dust, or maybe more dust, less aggregate. This can do a simulation, and then we do a selection for you. And basically, we guarantee the end result. Okay, we guarantee the end result. This is a business case that I did in Malaysia. So this is a real case. This is happening in Malaysia. So this is the original setup. This is the pressure. This is the throughput, CSS, and also the power use. This is the fraction of the material. Return material about 8.39%, 20 mm 35, chipping 18, quarry dust 37%. Okay, what we want to do here is to reduce the quarry dust. This is what we have recommended, and we have done it. After installation, we have changed the parameters. The throughput has reduced, but pressure and power have also reduced at the same time. So it's a bit difficult to see. So if you look at the comparison, this is original, this is test 1 result, this is test 2 result, and this is the difference. Throughput, yes, we have reduced 61 ton. Throughput. Throughput is what material goes through the crusher, not end product. What goes through the crusher. We have reduced the pressure. Reduced pressure means your crusher don't need to work that hard. Okay? Means your internal parts can last longer. Next is we also reduce power consumption, means lower cost of operation. Return material we have reduced as well. So less return, more end product going out. We have increased the 20 mm by 5 tons per hour, but this is the main reduction. We have reduced the dust by 41 tons per hour. Almost half to 40%. This is when you need to reduce your dust. By not changing crusher, only changing the crushing chamber. This is the gains, and this is in terms of money saving. So this is normally the boss that is interested to look at. How much I can save. Okay? This rate is given by the customer. So in power, they save 2,900 ringgit. Material, they save almost 2,000 ringgit. The restocking, double handling, they have saved 55,000. And coil dust double handling, they have saved 145,000. Altogether per month, they save 200,000. Saving. This is cost reduction. Means more money for the boss, or maybe more bonus. I don't know which one. Okay? And we can also increase your coil dust if you need more. Some customers actually want to increase coil dust. This is also another test, and this is the result. This return we have reduced, and maximum we have increased the coil dust by 27 tons per hour. This is extra revenue because now they have more coil dust to sell. So they earn more. They earn extra 100,000 per month. 100,000 is a lot. Even though they're using special crushing chamber, which is premium, this crushing chamber is only made in Sweden. And the cost of the crushing chamber per set is double the price of the normal crushing chamber. But the saving is more than enough to pay for it. Okay? Any question? Any question? We are basically ahead of time. Thanks to the class, because there's no question. And this makes me very worried. Very concerned. Very concerning issue. Because I'm not sure if you know, or you already know, or you don't know what you want to know. Okay? Hopefully you get this. So you need to study a bit. Tomorrow after the geology class, we will have a session together. Okay? We'll do a recap, quick recap, or any issue that you have during your study that you'd like to clarify. You can come to me to that. Okay? And before we end the day, so one thing about Quarry is being deceived as a very dirty, environmental, non-friendly, okay, always under the sun, a lot of dust, dangerous, okay, industry. And a lot of us actually perceive that way, and the way we work, the way we operate, the way we handle our operation, also in the same way. But actually, this is a very, very professional industry. It's only for the professional, not for any whatever person. You need to have the knowledge to actually in-depth study, look into it, okay, and then understand how to run it correctly. Okay? So treat yourself as professionals. Treat yourself as professionals. We are professionals and be proud of it. Okay, last words. Let's bring light to crushing. Okay? I'll see you guys tomorrow. Thank you. So early. Almost 1 hour early.